Good morning. This recording is for Pre-Algebra Chapter 8, Lesson 2, Equations with Two Variables. Ooh, X and Y's, you can handle it. All right, so let's talk about what you're going to be doing today. Or tomorrow, whenever you end up doing the assignment for this. You'll notice that most of the equations you're dealing with have an X and a Y. And that's great because you're going to be finding solutions for them, and a solution is an ordered pair that makes the equation true. And if you remember back from ordered pairs, which you should, and if not, I've got a very lovely poster in my classroom that will help you with ordered pairs. The first number is the X, and the second number is the Y. And we also talked about that yesterday when we were talking about functions, all right? So basically what we're going to do for some of this is we're going to see if an ordered pair given, like 1, 8, is a solution for a particular equation. So if we go ahead and look at the equation y equals 3x plus 5, what I'm going to basically do is replace the x and y with the information from the ordered pair. In this case, x is 1, y is 8. I'm going to replace them. And notice how I put the 1 in parentheses? That's very important, especially if your variable was being multiplied by a coefficient, and a coefficient is the number in front of the variable. If it's being multiplied, if your variable, in this case x, was being multiplied by 3 like it is here, and I replace it with a number, you want to maintain the fact that it was still being multiplied. So you want to put that number in parentheses so you can say it's 3 times 1, not 31. Okay, so it's very important that if you're replacing a letter that is being multiplied or even added or subtracted or even divided by another number, because you're replacing that variable with the number, it's important that you put it in parentheses because it helps you remember that it's not a number 31, it's like 3 times 1. Okay, anyway, you should know this by now. All right, moving on. So we're going to see if we get a true statement. So if we get a true statement, that means that the solution is correct. So let's go ahead and do order of operations. 3 times 1 is 3, and then 3 plus 5 is 8. So I get 8 equals 8, and that's like the truest statement in math you can get, other than, like 0 equals 0 or 1 equals 1. All right, and since this is a true statement, that means that the ordered pair, 1, 8, is a solution for y equals 3x plus 5. Sweet, so we know that it's a solution for that one. Let's try the next one. Y equals 4x plus 1. I'm going to replace the y with 8 and the x with 1. And I'm going to go ahead and use order of operations. 4 times 1 is 4, and then I'm going to add, and 8 equals 5. That is a false statement. That's one of the most falsest statements I've ever seen, other than, one is the loneliest heart. Anyway, so that is definitely a false statement, which means that the point 1, 8 is not a solution for the equation y equals 4x plus 1. Okay? Now, they are going to also ask you to figure out what a solution is, but they're going to give you some information already. They're going to give you either x or y. And if they give you x or y, they've basically given you half of the solution, because the solution is always written as an ordered pair. Always written as an ordered pair. All right, 2 variables, ordered pair, x, y, or a, b, or c, d, or e, f. Okay, they're usually alphabetical, usually, if they ever throw you for a loop like that. Okay, so if they give you, in this first example, x equals -3, you can go ahead and plug it in for x, and we know that x is already -3. We just need to figure out what y is in the ordered pair. All right, so I replaced x with -3, and I have y equals 2 times -3 plus 1. Well, I can go ahead and use order of operations, multiplication, and then addition. I'm going to figure out that y equals -5. So for this particular equation, y equals 2x plus 1, whenever x is -3, y will always be -5. But I could also go in and do it a different way. I could be like, well, what if x was 2? And then I could replace x with 2 and figure out what y was. And we'll be doing that a little bit later in this video. On to something else now. Okay, and again, ordered pair. Your answer must always be in an ordered pair. Don't just write -3, -5. Write parenthesis, -3, comma, -5, and parenthesis. You can do it. Please do it. I will dock you if you do not write it correctly. Okay? All right, so real-world application. The equation of T equals 21 minus 0.01 N models the normal low July temperature in degrees Celsius out Mount Rushmore, South Dakota. You know, the big mountain with all the presidents carved into it? Yeah, that's Mount Rushmore. All right, so in the equation, T is the temperature at N meters above the base of the mountain. So if you start at the base of the mountain and you go up, they're trying to figure out what the temperature will be when you're at a specific height, okay? So find the normal low July temperature at 300 meters above the base. So we're going to take the equation, and again, T is temperature and N is the number of meters above the base, and we're going to replace what we know. Well, we know that N is 300 meters, because it even tells us right there, okay? All right, so right there. All right, so now let's go ahead and do some math. 0.01 times 300 is 3, and then 21 minus 3 is 18. So when you're 300 meters above the base of the mountain, so basically you're 300 meters from the ground on the face of Mount Rushmore, it's going to be 18 degrees Celsius. It's a little chilly. It's a little cold. All right, now what about 700 meters? And also this is a relation. I forgot to talk about that. This is a relation, and it's a function actually, because for each x, or domain, in this case meters above the ground, there is only one y value, because every time a new x goes in there, it's going to generate, or excuse me, a new n goes in there, it's going to generate a new t. Okay, a new temperature range. I could put 301 meters above the base, and I'm going to get a slightly different t. All right, so for every x I put in, I get a different t, which does mean it's a function, and you should remember that from the last video. Okay, so again, if you do this one more time, but with 700, you're going to find out that t is 7 degrees Celsius. All right, before we move on to that, let's go ahead and talk about linear equations. Basically, everything you've been doing for the last 7 minutes, according to this recording, 7 minutes and 16 seconds, have been linear equations. And that means that if you were to take all of the solutions that you could think of, let's say you took 10 solutions for an equation, and they all work for the same equation, and you were to put them on a graph and connect the dots, you would get a straight line. And that's because basically anything with two variables and no exponents produces a straight line, and we call them linear. Line, linear, right? Makes sense? Line. It's got line even in it. Linear line equation. Okay? So any equation whose graph is a line, a straight line, these equations is a linear equation. These equations will not have exponents, but will have two variables, an input x and an output y. And, you know, they can use a and b, and they can use, you know, m and n, but a lot of the standards just stick to x and y. Okay, so again, we can figure out, is the given ordered pair a solution for the linear equation? Well, we're going to do what we did on the very first slide and just replace each x and each y with what the x and y is from the ordered pair. And then we're just going to see if we get a true statement. And so we're looking for true statements. So follow the order of operations. 2 times -1 is -2. -2 plus 1 is -1. And we get -1 equals -1. Hey, that's a true statement. Sweet. So since I got a true statement, the ordered pair is a solution for my equation. Sweet. Well, let's try this next one. We have y equals 3x minus 2, where x is -2 and y is 0, according to my ordered pair. I'm going to replace the y with 0 and the x with -2. Again, notice that I put it in parentheses so that I know that it's not 3 -2, it's actually 3 times -2. And I'm going to do order of operations, multiply it, then subtract, or I can add the opposite, which I prefer to do, and I get 0 equals -8, which is definitely a false statement. Therefore, the point -2, 0 is not a solution for this equation. Now, it could be a solution for a different equation, but considering we only care about the equation and the ordered pair given in this particular problem, we just basically needed to figure out if yes, it's a solution, or no, it's not a solution. Okay? And in this case, it's not a solution. All right, moving on. Okay, so linear equations are functions. And I kind of talked about that with the Mount Rushmore problem. The only thing is vertical lines are not functions when x equals something. And that's, you can basically see it because it doesn't pass the vertical line test. So vertical lines where for every value of y, x equals the same value is not a function. So if I look at this vertical line down here at the bottom, this orange one, right there, that orange one, x equals -3. That's because every point on the line, -3, 2, -3, -2, all have the same x value. And if you remember back from yesterday's lecture, this means that when you have exactly the same x but different y's, it's not a function, all right? And so, yes, notice how every point on this line has an x value of -3. P.S., this line goes on forever, so it doesn't just stop there. It's not like it's just like those points that is covering up. It's every single point that could be on that line. All right. Also, not a function, again, because each x value has a different y value. All right, good on that? Good. All right, but let's talk about horizontal lines real quick. Horizontal lines, in this case, y equals 2.5, because I couldn't get it to line up with one of the graph lines. So it's 2.5, has the same y value. But when we're talking about relations and functions, it's okay that every y goes with a different x. We don't care about that. So this line is a function. All right, so for every value of x, y is still 2.5, but that's okay because every value of x is different in this case. All right, there you go. All right, let's move on. The last slide, graphing by solving for y. Note if the book does not give you any specific x values, like before they're like, hey, use -3 or use -2 for x and then tell me what y is. If they don't give you any specific, I want you to use -2, 0, and 2. Basically because they're easy to graph and they're easy to do math with, okay? So let's go ahead and do this. First thing you're going to do is create a table of values, though for some of your equations, if y isn't by itself, you might want to solve for y, so it's a little easier to do your math. You don't have to, but it might make your life a little easier, all right? And then once we've made a table of values, we're going to graph them and then connect the dots. And then your hint, if your line isn't straight, then you did some math incorrectly to get the wrong point, okay? So we're going to go ahead and we're going to graph this line up here, 2x plus y equals 3. And notice it is a linear equation. It has two variables, x and y, and there's no exponents. So this is definitely going to form a straight line as long as we do the math correctly. So I'm going to solve this for y to get y by itself. I'm going to minus 2x on both sides. I'm going to get y equals -2x plus 3. This is the equation I'm going to use in my table of values. And here's my table of values. And I want you guys to get used to making table of values because they're going to come in super handy for the rest of your life. And it helps you keep your information organized. So I have an x column and I have a xy column. And then in the middle, I put my space to do all of my math. So again, I'm going to have you use -2, 0, and 2, because they don't give you any specific ones. Sometimes they'll be like, you need to graph 5, 6, and 7. Well, here, if they don't tell you which ones to use -2, 0, and 2. And the other thing is that I want 3 points every time. No slacking. All right, let's pause that for a second because I'm getting ahead of myself. The reason I want 3 lines or 3 points graphed every time is because if you graph 2 points, you're going to automatically get a straight line when you connect the dots. This means that if you make a mistake, you'll never notice it. So by using 3 points, you will notice if one of them doesn't line up. Okay? So, all right, let's go ahead and do some math. If I plug in -2 for x, I'm going to get y equals 7. All right? So if y equals 7 and x equals 2, the point, -2, 7, is right here. Right there, okay? Now I'm going to plug in 0 for x. -2 times 0 is 0, plus 3 is 3, which means when x is 0, y is 3. All right, and then I'm going to graph that point, which is right there. And then I'm going to do the last point, which is x equals 2. So if x equals 2, we get -2 times 2 plus 3, which means y equals -1, and there is that last point. All right, now I have 3 points. Now I'm going to connect the dots. hey, it's a straight line, which means I probably did all of my math correctly, but it also means that if I hadn't done my math correctly, at least one of the dots wouldn't line up and I wouldn't be able to draw a straight line. Okay, I'm done, guys. Sorry this was long. Bye.